Hi, Professor. So today I'm going to be demonstrating my master's project. I have basically built a credential spear phishing detector. So what I have here is a mail server on my own system. So uh, I also have an intrusion detection system. So I put on a PCAP file to capture those network URLs on EN0, and as on my computer you can see that that is the Wi-Fi port. So I do that, and then what happens is when we send emails across the organization, which is my system for now. So what I'm doing is I'm sending an email to my professor, um, using my organization's LDAP credential, and I'm basically trying to send him this file via email. So when I send him this file, what happens is this file gets opened up and the link that I used gets opened up. So this file is parsed, and as I told you, I am starting an intrusion detection system. So what I had done was to into that intrusion detection system where I've used Bro open source tools, I captured these URLs and I have opened them here. So tried to open them in my browser to see if they are malicious or not. And yeah, and then when you see the entire report here, you can see that these URLs were captured, how many times these were seen, and yeah, and the domain was seen how many times, and um, similarly, the earliest time this was seen and this was last seen when that all those information are available. Um, so as you can see, it was last seen on today, but earliest it was seen was yesterday. Uh, so that's one thing, and then what happens here is also that. Um, when I try to uh, use someone else's email with a different name, let's say I have got access to credentials of Harsh Bajaj, and I try to change the username, and I try sending him an email. You can see here that it raises an alert that I've already seen this email with a different name. So if you see that it says the spoofing. So this is how I detect the name spoofing detection. I will also be going back to the PCAP file and how I do the intrusion detection system in just a bit. So what I'm doing here is now I'm trying to change the, let's say the attacker is very intelligent and he like does like changes um uh, the LDAP, and he hacks the LDAP, and now he's created his own account. So he says random at example.com, and he uses my name, which is nothing but address spoofing. So now when he tries to send an email, you will see here, yes, the URLs get parsed, but you will see that I have already seen these names with the different email. I've seen this name with a different email. So Harsh Bajaj was seen earlier as Harsh Bajaj at example.com, but now it's random at example.com. So this log will be raised to you as an alert in the system. So now I want to show you what my Bro tool is doing. So if I just open the Bro tool, Bro logs, I'll just so I have the Bro logs here. So basically, it tells me when you opened the groups.google.com, as it analyzed it, it went through several intermediate packets. So even if the attacker tries uh, to create a cross-site request forgery, so I'll get all the details, like it was from a Google email, and then you went to several intermediate packets, and then you basically reach to a group. So as we can see here, it tells me from where the request was generated. You can see it was me from UIC Wi-Fi. And then the other thing is you can also see that what kind of timestamp, and then you can see what packets protocol did I use to communicate. You can get all my details, and also the details of the server in detail, like what was the exact path I referred to in that request. So all these paths that the URL has can be picked up from here. There is also another http.log file which is generated. So that also gives us a hint about the URL that we used and we went through in the requests we made. And then we have our uh, yes, so basically to have our timestamp, and our machine learning tool will leverage these timestamp, which I'll show you in a bit. So here is my machine learning tool. So basically I've used Python notebook and programmed everything in Python. So what I've done is first taken about the sender reputation feature. Sender reputation feature is nothing but talking about a particular email sender and how reliable he is or how likely he is to carry out a phishing attack. So as you saw, I didn't have much data here. So I just have barely one or two lines in my logs. So I didn't have much data about the longitude, latitude of users and like what kind of spoofing they have been carrying out. I just have one or two alerts in this system here. So I decided to look out for something on the web, and I found the Enron email dataset. Enron was a huge company which was impacted by phishing emails. So phishing emails occur on uh, a person to carry out some advantage out of him to lure the victim to get advantage. Now, spear phishing emails happen on person of interest. So this data set gives me the access to those person of interest, and we filter out that data, and we just focus on the person of interest, what mails were sent to him and what mails were received by him. So basically spear phishing is researching a particular person and trying to compromise him. So here I have taken the data set which exactly marks that. So I have some person of interest where POI was equal to 1, so I chose that, and I carried out an analysis as to when these people are compromised and what kind of names were used to compromise them. So as you can see, I have used something like from this person to POI, and then I have used something like interest employee to messages and from messages. The messages that were sent from this employee to others, and the messages that were received to this employee from other employees. So here I can form a graph based on how frequency of emails. As here I have just made a plot to just analyze the data first. So then I have seen that how many times in the entire data set these person of interest come in the whole traffic. As you can see, person of interest come very less in terms of the other people, like non person of interest, which is denoted by 0 here. So what I did, I separated out these person of interests and their features. And then on their features, I can carry out what were the names that were used in the from email that was sent, to emails that were sent to them. And then carry out the Now that I have a record of only the person of interest in my data set, so I'm going to carry out analysis that how he has been interacting. So how he has been interacting means that how many messages he sends, what kind of messages he sends. So as you can see, there is like from messages here, from this person to person of interest. So I am taking a particular data point and trying to link it with the person of interest and trying to find a fraction of emails or the frequency of emails which will give me about the interaction of other employees with these person of interest, or the person of interest's interaction with other employees. What is the frequency, what are the names used, who are the from and to people. So from these two messages I basically get some names, a string. So that I plot in a graph, and basis of 0 1 I determine that blue are people of not interest, and these yellow ones are people of interest. So whenever I see outlier in the name, that guy is a red signal for us. He is an outlier. So now, as I've been talking about outlier and anomalies, so what does that all come down to in terms of machine learning? It comes down to SVM classifier or KNN neighboring or random forest. So I tried three different techniques on this data set, which I boiled down to only person of interest, his messages, his names that he was talking to, the messages he was sending. So I decide to carry out outlier detection, and you can see here that KNN wins with 87.22% accuracy. So basically, what each of them is trying to do is unsupervised learning. Like SVM classifier, as we know, does not have a fixed boundary. It is known for a curved boundary. So it is usually like easier for it to form a boundary or like a outlier classification. As you can see, this will not be a straight line here between the outlier and the non-outliers usually. If you see in most of the data set, like in the graph shown here, you will need a sort of curve boundary. So I chose SVM classifier. Random forest is another technique like decision tree, but it is more stronger, and it is used to like classify the message in terms of a good sender or a bad sender. So basically, we are trying to carry out reputation here. So all we care about is he a good sender or a bad sender? So, but the winner is k nearest neighbors, because in these models, unsupervised learning will work the best, because every time you cannot predict attacker's name and other details, there are new attackers born every single minute in the market. So I finally carry out an analysis about who was the person of interest, what is the email address, to show you that where I conducted my analysis, and on like whatever little data we have about spear phishing, how accurately we are able to predict. Then the other fact comes about content based features. This is also very similar to name spoofing activity. So this also allows us to determine the reputation of the sender. So basically, if you have a good grammar, if you write well, obviously your reputation in office is said to be good, right? So this is something that I picked from there. What I've done is use principal component analysis on the content. As I earlier described to you, I'm taking in the person of interest messages, I'm taking in his content, and trying to decide whether it is that same person or not. How I'll determine that is using outlier detection, anomaly detection. I've used principal component analysis, which is a similar technique like k-means clustering. It takes like components as two, so it takes two data points and tries to cluster them based on a particular axis and distance. Based on axis, it will decide whether they are outlier or close to each other. So as you can see in the bottom left, these pink dots are close to each other, but on the bottom right, these pink dots are away from each other, so they are outliers. um, I've also used KNN nearest neighbors, so that is another anomaly. In K nearest neighbors, I've taken a set of three clusters because I kept tuning these hyperparameters till I reached the accurate point and I could find out the words which are or from the content which are usually used in phishing attacks. So these are how I prepared. So basically, n equal to 3 means it's a reasonable value set for emails. What it does is it takes three set of emails and it tries to combine them and see if they have a strong match between them. If so, place them in a cluster. Again, in the bottom left, you see those coordinate points together. Why? Because in the bottom left, you will see those 0.0 and 0.2 as the index. So the points who just have zero point 0.2 distance between them or a zero point 0.0 distance between them, they are very tightly clustered. So you know if I'm writing emails again and again day by day, you will see similarity between my emails. So it is lie in the bottom left corner. But on the other hand, if you have attackers coming in, which happened to this company, that's why you have more points toward bottom right, and I have made sure to color them differently so that it's easier and fascinating for the viewers to look at. Then I have generated a set of TF-IDF vectorizer. It's a term frequency vectorizer. So term frequency, what it does, it takes these words and checks the frequency that they occur. So the highest frequency ones are the misspelled ones. As you can see in the column number 2 here, there is like reordan, and all these spelling mistakes are CAISO. These spelling mistakes are happening in attacker's email. So from here, you'll get an idea of the term frequency. Wherever the term frequency is higher, you are sure that these particular emails are said to have been generated from a phishing attacker. Then I also did a research about URL reputation. What comes here is, as you saw in the Bro tool, I was analyzing the URL from where it generated, where it went, and what was the path of the URL, how many queries are there. So in that, I am basically trying to capture the certain aspects about URL which will help me decide whether this URL is phishing or not phishing. So here I essentially come down to use classification model. But before that, I have done research on the internet and also discussed with my professor about the features that we should use in a URL which marks it as suspicious. It is something like the count the delimiters, count the dots. So what happens, you must have also seen microsoft.fish.com or linkedin.fish.com. These URLs are highly suspicious. So the dots in the URL matter. The other thing that essentially matters, which we have seen common examples of, are like count queries. So if you see XSS attacks, so if there are more number of queries, that is a alert for me. That might be like a XSS attack. So uh, that is something we need to be careful about. And uh, basically what we have to see here is those features don't occur in the URL, and if they do occur, they are classified as suspicious. So I create basically a train and test features, and I from this UCI dataset, I get information about these URLs, like what was the URL, what were the URL dots, right, and IP address was there or not. So I URLs another thing. If you have a IP, just the IP address in the URL, that URL is another red flag, because usually, like, somebody, if he's sharing links with you or if he's talking some URL with you, he'll have google.com or amazon.com on it. So that should never occur like IP. So here I've used techniques like gradient boosting, logistic regression, and Gaussian Navy Bayes algorithm, basically a probabilistic techniques to classify whether a URL is phishing or not. So to classify the URLs, phishing or not, we essentially use the feature set that we derived above, and the feature set we are converting into a train test dataset based on 80% train and 20% test, and then we use scikit-learn library to put it in those classifiers that we have set up here. So we have three classifiers. We iteratively process in those and determine which classifier will be best for us moving forward. So as you can clearly see, logistic regression and gradient boosting are the most effective technique. What these logistic regression and gradient boosting are, I'll give you a quick overview. So logistic regression is basically based on probability. So what is the probability that this URL is likely to be phished? That is what this algorithm does internally when I pass this feature set to it. Basically, as you can see, I'm passing here some values on this. So as I had some values coming from here, so I passed them like yahoo.co.jp and dots, and you can see the URL length. All these factors are being passed to it, and it is going to determine based on a probability. So once that algorithm is done, then the probabilistic base, then we move on to some higher level analysis, which is gradient boosting. So gradient boosting is like a gradient descent predictor. So what happens is that it is trying to converge onto some set of stability. So gradient descent uh, is where the name of gradient boosting comes from. It is trying to converge to a optimum value, a stable value. So here gradient boosting specifies a predictor and tries to see based on the prediction whether this URL is phished or not. And yeah, so we can see that it has generated a very good accuracy of 87.4%, basically trying to predict whether a URL is phishing or not phishing based on some gradient that it decides and tries to converge to the optimum. So this was my analysis of the credential spear phishing attack. Hope you liked it. There was sender reputation, URL reputation, bro IDS, SMTP servers. Thank you for your time.